Hello students, welcome to E-Physics. Have you ever wondered how magnets work? What makes them attract some objects and repel others? Well, it's all about the fascinating world of magnetic fields and atomic particles. To understand magnets, we must dive into the microscopic world of atoms. Everything in the universe, including magnets, is made up of these tiny particles. Atoms themselves are composed of protons, neutrons, and electrons. The behavior of these electrons is what gives rise to magnetism. In most objects, the electrons spin in random directions, but in magnets, something extraordinary happens. The electrons align and spin in the same direction, creating a magnetic field. This field is the power behind the magnet, the invisible force that pulls other magnetic objects towards it or pushes them away. Imagine a bar magnet. Think of it as a kingdom of atoms, with each electron spinning in unison with its neighbors, all pointing in the same direction. This alignment creates a powerful magnetic field that extends from the North Pole to the South Pole of the magnet. The law of magnetism states that unlike poles attract while like poles repel each other. So when you bring the North Pole of one magnet close to the South Pole of another, they attract. But if you try to push two North Poles or two South Poles together, they repel each other. This is because the magnetic field lines that flow from north to south resist being forced in the opposite direction. But what about objects that aren't magnets? How do they interact with this force? Well, the answer lies in the fact that all materials are affected to some degree by a magnetic field. Some, like iron and nickel, are strongly attracted to magnets. Others, like plastic or wood, are barely affected at all. This is because the atomic structure of these materials determines how they respond to a magnetic field. Now you might wonder, can magnets ever lose their magnetism? Yes, they can. Applying heat or a strong opposing magnetic field can disrupt the orderly spinning of the electrons, causing the magnet to lose its magnetic properties. In summary, magnets work due to the alignment and spin of their electrons, creating a magnetic field. This field allows magnets to attract or repel other magnets and magnetic materials. The strength and direction of this field determine how objects will interact with the magnet. Whether it's sticking your favorite picture on the fridge or powering the motor in an electric car, the magic of magnets is all around us, making our world work in amazing ways.